Welcome to today's Explainer. We are going to completely demystify Chapter 8, digging into how we construct, manage, and actually talk to databases. I like to think of database management kind of like building a house. You don't just dump a bunch of your stuff into an empty dirt lot. You lay a solid foundation, you frame the walls, define the specific rooms, and you build hallways so you can easily find exactly what you need later on. Well, in the digital world, relational database management systems are the neighborhoods. And today, we're going to learn how to build our very own house using structured query language, or SQL. Here is our blueprint for today. We're going to cover 1. Meet SQL and databases. 2. Data types and constraints. 3. Creating your first table. 4. Querying, which is basically asking the data questions. And 5. Modifying and deleting records. Let's get into it. All right, Section 1, Meet SQL and databases. We're going to start by looking at the logical structure. So there's this really fascinating quote from E.F. Codd. He's essentially the brilliant architect behind the entire relational database model. He said his main motivation was to provide a sharp and clear boundary between the logical and physical aspects of database management. Now, what does that actually mean for us? Well, it means you absolutely do not need to stress about exactly how the data is physically, magnetically saved onto a hard drive somewhere. You only need to think about the logical structure, like how the data actually relates to itself. SQL is going to take care of all that heavy lifting for you. And that brings us perfectly to the ultimate tool we use to interact with this logical structure, structured query language, or SQL. It's the absolute most popular query language out there, used by massive systems like MySQL, Oracle, and SQL Server. But here is the absolute best part about it. It is incredibly accessible. SQL is quite literally made up of descriptive English words, plus it's case insensitive. So typing the word name in all capital letters and name in all lowercase letters, SQL reads them exactly the same way. You don't have to spell out exactly how to get the data. You just tell SQL what you want, and it handles the rest. Moving right along to Section 2, Data Types and Constraints. These are your foundational building blocks. Think of these as the specific materials you're using to build your house. In MySQL, you've got a few essential building blocks. First up is int, which stands for an integer. That takes up 4 bytes of storage, which literally gives you a range from -2 billion all the way up to +2 billion. Crazy, right? Then we have float, which holds your numbers with decimal points, also taking up 4 bytes. And crucially, we have date. Now, date uses a very specific format: a 4-digit year, a dash, a 2-digit month, a dash, and a 2-digit day. Knowing these data types just ensures you're using the right materials in the right rooms. Okay, so the next crucial step is keeping all of these records organized and securely connected. We do that using constraints. Think of a primary key as the totally unique address of a specific room in your house. It uniquely identifies a single record, kind of like a student's roll number. And because it's so important, it cannot be blank. It cannot be what we call null. A foreign key, on the flip side, is a lot like the hallway connecting different rooms together. It declares that an index in one table is directly related to an index over in another table, like, say, linking a student's ID in an attendance table straight back to their main student profile table. Section 3, Creating your first table. It is time to start putting up the walls. So actively constructing a table follows an incredibly simple step-by-step procedure. First, you just use the create table statement. Then you name it. Maybe something straightforward like student. Next, inside a set of parentheses, you just list out your columns, which we also call attributes. For every single column, you assign one of those data types we just talked about, like int or date. And finally, you apply your constraints. You essentially tell SQL, hey, this roll number column, that's my primary key. Also, just a quick note, by default, attributes can take null or completely empty values, unless you explicitly specify not null or it happens to be a primary key. See? It really is just like reading a basic blueprint. Let's dive into Section 4, Querying. Basically, asking the data questions so we can locate specific items. Let's pose a real-world scenario here to show you just how powerful a well-crafted database query can be. Imagine we've got an employee table. It has columns for employee number, name, salary, bonus, and department ID. If we want to find just the names of the employees who make a salary strictly greater than $50,000, how do we actually ask the database to fetch that for us? Well, the answer brilliantly illustrates just how intuitive SQL really is. The command is select ename from employee where salary is greater than $50,000. It practically reads like a normal sentence. We tell SQL exactly what we want, which is the ename column. We tell it where to look, the employee table, and we give it our exact filter, where the salary is mathematically greater than 50,000. Oh, and definitely don't forget that little semicolon at the end. That is literally the period at the end of an SQL sentence. Now, beyond simple greater than or less than filters, SQL hooks us up with some seriously powerful tools to refine our searches. We can use aliases to temporarily rename an output column. So if we calculate a yearly pay, we can just display it nicely as annual salary in quotes. The distinct clause is an absolute game changer. It returns records without any repetition. So if you just want to see unique department numbers without seeing duplicates for every single employee, distinct handles that. Between is a great comparison operator that simply checks if a value falls inside a specific range. And not in lets you completely exclude a defined list of values, like selecting employees where their department ID is not in Department 1 or Department 2. These are basically your highly advanced search filters. Finally, Section 5, modifying and deleting records. Let's talk about handling renovations. Say we have a student and their government ID, their GUID, was originally left blank in our system as a null value. But now they've handed it in and we need to update their file. We use the update command. We say update student, telling SQL the exact table to modify. Then we say set GUID equals 1010101010, but here is the absolute most important part. Right at the end, where roll number equals 3. That where clause ensures we are only updating that one specific record for the student with roll number 3. Okay, I need you to pay super close attention to this next point because it is absolutely crucial. When you are using the delete statement to remove a record, you must always use the where clause to specify exactly which record you are deleting. If you just type delete from student without a where clause, well, SQL just assumes you want to clear the entire table out. All of your records will be instantly deleted. Skipping the where clause here is quite literally like accidentally taking a bulldozer to your entire digital house. Always double check those where conditions. So, we've built the foundation, we've framed the walls, and we've learned how to find our stuff. To wrap this explainer up, I want to leave you with a really thought-provoking prompt straight from the chapter. Next time you pull out your phone, open your contact list, and type just the very first letter of a friend's name, notice how that list instantly filters down to show only names containing that exact character. How is that like an SQL query in action? Think about it. Take a moment today to look at the apps you use all the time and try to visualize the SQL statements operating silently behind the scenes, retrieving exactly what you need right when you need it. Thanks for hanging out with me on this explainer, and happy querying!